Hey students, this is your notes video for lesson 9.2 on lines of fit. So first of all, a line of fit is a line drawn on a scatter plot which is close to most of the data points. It won't be exactly on the data points. It won't touch them all, but it should be close to all of them. So in this first example, we're going to estimate a line of fit. So first we're going to make a scatter plot based on our data. So we have months along the x-axis. And along the y-axis, we have depth in feet. And it looks like we need to make it up to 20. So I think I'll count by twos. Okay, so now we have our graph labeled. Now we just need to put each of these points on our scatter plot. So we have the point 0, 20, 119, 2, 15, 3, 13, 4, 11, 5, 10, 6, 8, 7, 7, 8, 5. Then we can write an equation that we think is the best line of fit. And it looks like each time we're going forward by 1 month, we go down by 2 feet. So I think the slope here is about -2. And the y-intercept, of course, is 20. So my line would be something like y equals -2x plus 20. All right, and then next we're asked to interpret the slope and the y-intercept. So the slope is -2, and that tells us that the depth of the river decreases 2 feet per month. So that's what that m equals -2 means. And the b equals 20 means that the depth of the river is 20 feet just after monsoon season. So before it starts decreasing, that highest point is at 20 feet. And then our last step is to predict the depth in month 9. So now that we have our equation, y equals -2x plus 20, we can just substitute 9 for x, and we get y equals -18 plus 20, or 2 feet. All right, so next we're going to talk about how graphing calculators and Desmos, which is a graphing calculator, can use a method called linear regression, and they will do a much better job than either you or I could do in finding a line of fit. And so we call it a line of best fit when this is done using technology, using this process called linear regression. Now, the calculator will often give you an R value, or the correlation coefficient, which ranges from -1 to 1. And what that R value means is an R value that's -1 or close to -1 is a really strong negative correlation. So if you look at our example with the depth of the river, we can see that those points follow almost along in a straight line with a negative slope. So that has an R value really, really close to -1. It's almost a straight line as it is. If we have an R value of 0, that means there is no correlation. You have a scatter plot that just has points on it that doesn't really seem to have a correlation between one data set and the other. And then if we have an R value close to 1, that means it's a really, really strong positive correlation. So it's close to being in a straight line with a positive slope. So we're going to talk now about how to use technology to find a line of best fit. And we have this data here about ticket sales from years 0 to 11, where x equals 0 really means the year 2000, and x equals 1 means the year 2001. And we have ticket sales in billions of dollars. And we're going to use Desmos to find this equation. So step 1 is going to be, you're going to go into your Desmos.com and you're going to click on this plus sign that you see in the upper left-hand corner. And we've done f of x expressions there before, but what you're going to do is click on table. And what will come up is an XY table where you can fill in the x and the y values. So here I have our points that are on the table, like the 0.016, the 0.117, etc. So I just entered in all of those points, and you should do the same. And once you do that, once you have all the points in there, it's going to show you the scatter plot. So here we can see what that scatter plot looks like. So we can tell from looking at this that this has a positive correlation. We can see that as x is getting larger, y is getting larger as well. And what you're going to do to find that line of best fit is you're going to go back to that plus sign in the upper left-hand corner, and now you're going to choose that f of x expression like we've done in the past. And here's what you're going to write in it. y1, and then instead of an equal sign, you're going to use this little tilde that's in the upper left-hand corner, and then mx1 plus b. So it looks a lot like y equals mx plus b, but what we're telling Desmos is that we want to use this table of values. We want to use all of those values of x and y that we have graphed, and we want to find this line of best fit. So this is the way you need to write it in for that to happen. And when you do, right away, it tells you the R value, that correlation coefficient, and we can see that it is an R value really close to 1. It's a strong positive correlation. It also tells us the slope, 1.50699. We can say that's about 1.5. And our y-intercept, our b value, is 16.2949. We'll call that about 16.3. So if we round to the nearest tenth like we did, our equation here will be y equals 1.5x plus 16.3. And we can see once we have written that equation in, we can see what that line of best fit actually looks like. So they've drawn the line here, and we can see that all of those points are pretty close to the line, as close as they possibly could be. And our correlation coefficient, we said, was 0.9818. That's really, really close to 1. So that's a strong positive correlation. Notice that almost all of these points are actually touching the line. That's a sign of a really strong correlation. If we had more points that were further away from the line, we would have a weaker correlation. Okay, so go ahead and try the on your own, and by not only making the scatter plot yourself and estimating a line of fit, but you're going to use those the process we just went through and use Desmos to create a line of best fit as well.